In this screencast, we'll see how to use Statkey to do a randomization hypothesis test. And the research question we'll be trying to answer is, do more than 75% of adults in the United States exercise on a regular basis? So we want to know if the true population proportion is more than 0.75. So the first step of hypothesis test is to state the null and alternative hypothesis. So the null hypothesis is that P, the population proportion, is equal to 0.75, 75%. And the alternative, the thing we want to know if we have evidence in favor of, is that P is greater than 75%. So there's our null and alternative. Now we need to figure out how to use Statkey to get a p-value. And here, remember, p is uppercase P. It stands for the p-value of a hypothesis test. And we'll talk about what that means more at the end. So let's go to our data. This is the Excel data. This is for random 1,000 adults in the United States. And we need to know how many of them exercise in the last month, and we'll take that as being regular exercise. So exercise any, that's column B. And notice we've got mostly ones, some zeros. And so to figure out how many of them have exercised in the last month, how many ones we have, we need to filter. So to filter, first we choose this whole first row, and then we filter over here where it says sort and filter, and we hit filter. And now we see these drop-down menus, and it will let me unclick the zero, so only one is checked. And then down here in the corner, it tells me 767 of 1,000 records found. So of the 1,000 people in our study, 767 of them had exercised in the last month. Okay, so now let's go to Statkey and go to randomization hypothesis test for a single proportion. And I need to edit the data. So it says it wants two things, the count and the sample size. Well, the sample size was the 1,000 people in my study, and the count was the 767 who had exercised. Notice that our sample proportion, 0.767, that is more than 0.75. But we want to know, is it so much more as to be statistically significant? The null hypothesis is p equals 0.75, so we have to change it from the default to 0.75 and hit OK. And now I generate 1,000 bootstrap samples. So here's 0.75, 0.767 is going to be up here somewhere. To get the p-values, since our alternative was greater than, we only care about what's up here, we just click on right tail. And I don't want to see where the 0.776 is, I want to see where 0.767 is. So I'm comparing the data I have to the 0.75. So I change this to 0.767, the actual proportion I saw in my data. Hit OK, and it tells me 0.107, about 0.11. So of my 1,000 bootstrap samples, 11 of them, or actually of the 1,000 bootstrap samples, 107 of them, 10.7%, were as big or bigger than the 0.767 in our actual data. So that's our estimate for the p-value. Come back here. P-value equals, it's really approximately equals, 0.107. So what does this mean? If the null hypothesis were correct, then there would be a 0.107 probability of getting sample data as extreme as we observed. So we had some real data. Would it be surprising if the actual population proportion were 0.75, if the null hypothesis were correct? Not that surprising. It would happen about almost 11% of the time. So our decision, we do not reject the null hypothesis. It just wouldn't be that surprising to get 767 out of 1,000 if the actual population proportion were 0.75. This 0.107 isn't small enough. How small would it have to be? Well, the conventional figure is 0.05. Something that happens 5% of the time is considered unusual. Something that happens almost 11% of the time, not that unusual. So a conclusion would be we do not have evidence that the alternative is true, that p is greater than 0.75. And the rationale behind that, if p were equal to 0.75, it would be almost an 11% probability of getting a sample proportion as high as or higher than we actually did. The data we collected would not be that surprising. So the thing I want you to focus on for this video is just how I used how I used Statkey to do it. I went to the appropriate randomization hypothesis test, entered the data. That's not the one we just did, of course. Entered the data, adjusted the null hypothesis, took a bootstrap sample, and then looked to see how it compared to what I actually had and what proportion of my bootstrap samples was extreme as the ones that in my original sample. And different randomization hypothesis tests follow the same general rules.